So the next part of conic sections that we're going to talk about are parabolas. If you can notice, this particular parabola in blue is really when you slice this cone at an angle and it goes all the way through the base. So that's how you get your parabola. Now we've been talking about parabolas throughout Chapter 7. This time we're actually going to look at parabolas in a slightly different manner. What you see here is the parabola drawn in red, and then you have a line and a point. Each parabola is actually defined by the point and the line, and the way that it works is this. This point is called the focus. It is always on the inside of the parabola. And then the line is the directrix. And it's always on the outside of the parabola. Now the distance between the focus and the vertex is equal to the distance between the directrix and the vertex. What defines a parabola is the distance of this point to any given point on the parabola is equal to the distance on the parabola from that line. So these distances are equal. No matter where you are on the parabola, these distances are equal. And that's the definition of a parabola. There is a proof in your textbook on page 412 if you're interested in looking at it. It actually uses the distance formula to calculate that. We are not going to get into that in this class this year. But it is important for you to understand where these terms come from. What we'll be doing this year is using the information about the focus and the directrix to write equations of parabolas. What you're looking at right now is actually in your textbook as well. It's on page 414. The first thing that I want you to notice is that not only can we have happy and sad face parabolas, but we can have C's and backward C's. And the way that the parabola faces really depends on what's being squared. If you look here, the x is squared, so it's your regular happy face or sad face. Here the y is squared, so that's why you have the C, or you would have a backward C. Some important information. That A term does the same thing. If your A term is positive, happy face, or you have a C. If the A term is negative, that's when you get your sad face or the backward C. The focus is going to lie on the same vertical line. If you've got an up or down parabola, the focus will lie on the same horizontal line if you have a side-to-side parabola. The directrix is going to be an equation of a line. Right, so this is a point, but your directrix is a line, and make sure that you always write it as a line. The directrix will just mirror across your vertex from the focus, and then it will go kind of in the opposite direction of your parabola. So this parabola is going up, so your directrix goes side to side. This parabola is going to the side, the directrix goes up and down. The axis of symmetry is the line that goes directly through the vertex and the focus. And again, it's an equation of a line. The last thing that you need to understand is how to get this value C. Normally, if we have A, we can find out C, which is this distance, by using this formula 1 over 4C. And if we have A, we can very easily solve for C. So let's take a look at a few problems. All right, and I've told you that I'm not expecting you to graph these. However, sometimes an image will help you to understand what's supposed to happen. So a parabola has a focus of 4, -3. So 4, -3 is here. That's the focus. And the directrix is at y equals 1. So this is my line, y equals 1. I need to find the vertex. The vertex is exactly in between these 2 points. So what I need is the midpoint of the line segment here. I can call this point 4, 1, and if I look for the midpoint of that, I have 4 plus 4 over 2, comma, 1 plus negative 3 over 2. So this gives me 4, negative 1. So the vertex is right here at 4, negative 1. And although it doesn't ask, we actually could sketch this parabola. Remember that the focus needs to be on the inside of the parabola, so once I've got this information, really this is kind of what it's going to look like. Okay, so now we are given a focus and a directrix, and we are asked to write the equation of the parabola. Now, in your textbook, it's going to show you how to set the distances equal and do this big long solution. I'm actually going to skip that because what I want you to do is use that information that I showed you that's on page 414. So again, the first thing I'm going to do, even though I'm not required to graph, I'm going to sketch just a small graph so that I can see what's going on. I have a focus at the point 1, 0, that's here. My directrix is at y equals 3. So what I know is that my vertex is right in between those. The x-coordinate of the vertex is 1. The y-coordinate of the vertex, right, so it's 3 plus 0 over 2. It's 3 halves. Now that I have a vertex, I can write my equation in vertex form. Y minus 3 halves is equal to a times x minus 1 squared. But I need to know what a is, and I have no other points on this parabola. So what I need to do now is use what I know about this distance c. That distance is 3 halves. So I know that a is equal to 1 divided by 4c. So I can say that a is equal to 1 divided by 4 times 3 halves. That becomes 1/6. Now, again, I need to use a little bit more logic and reasoning over just mathematics. Because my focus is here, that makes this a sad face parabola. And because I have a sad face parabola, this a value must be negative. So the equation for this parabola The next type of problem that you're likely to see is being given an equation and you are being asked to find axis, vertex, focus, and directrix of parabolas. This is where completing the square starts to become important. What I want to do on parabolas is I want to separate the x values and the y values with the equal sign. So I'll have x squared minus 2x is equal to 2y. And then I'll complete the square. So that becomes plus 1, and that equals 2y plus 1. On the left, I get x minus 1, quantity squared. On the right, I'm actually going to factor out that 2 and make that y plus 1/2. Then I need to bring this 2 over to the other side. So that's going to give us 1/2 x minus 1 squared is equal to y plus 1/2. We tend to not like our equations this way. We tend to like y first. Now that I'm here, I need axis, vertex, focus, and directrix. Let's do the ones that are really easy, like the vertex. The vertex is 1, negative 1/2. The axis of symmetry. This is an up and down parabola because my x's are squared. So my axis of symmetry is a vertical line, which means it's going to be x equals, and it'll be x equals my x value of the vertex, which is 1. For the focus, we need to use this A value to figure out what our C value is. And remember, the A value is here, and the C value is that distance, right? So if this is my parabola, right? So you're going to have a focus and a directrix, and this is the distance. That's C. So I remember that A is equal to 1 over 4C, which means that 1/2 is equal to 1 over 4C. Cross multiplying, or whatever you want to do, essentially that means that 2 has to equal 4 times C. So C is 1/2. What this tells me is that my focus is a 1/2 unit above my vertex, and I know that it's above because this is a happy face parabola, and my directrix is a 1/2 unit below the vertex. So the focus, going to have the same x coordinate, 1/2 a unit above is just going to be 0. The directrix will be 1/2 a unit below, which means it'll be at -1. Alright, this last problem is one of the trickiest ones we're going to do, and the reason is because you've got a y squared. That's not a typo. The first thing that you need to think about when you see a y squared is this parabola is going to be sideways. So it's either going to look like this or it's going to look like this. Now that you have that in mind, you know that your focus and directrix are going to have certain characteristics as well. Okay, so let's get started. I always want to separate my x's and y's. So what I'll do is y squared is equal to -2x. Luckily, I don't have to complete the square, but it is easier if we can see these things in vertex form. So I'm going to make the left side y minus 0 squared. And I'll make the right side -2 times x minus 0. Now, because the y is what's squared, I need this in front of it. So I have to divide by -2 on both sides. That gives me -1/2. Y minus 0 squared is equal to x minus 0. And again, because it's sideways, we kind of like our x's on the other side. So the proper form of this equation, I would say, looks like this. Now that we've gotten that done, we need axis, vertex, focus, and directrix. I, again, always start with the vertex because it's pretty easy to see straight out of this equation, and the vertex is at 0, 0. I can also do the axis pretty easily because I know it's a sideways parabola. My axis will be a horizontal line, so it will be y equals 0. So now, focus and directrix. For focus and directrix, we need to know what the distance is from the vertex to each one of these components. And to find the distance, we want that c value. So we use a is equal to 1 over 4c. And here a is -1/2 is equal to 1 over 4c. So again, in this case, c is equal to 1/2. That means that the focus is 1/2 unit away from the vertex, and the directrix is 1/2 unit away. So now we need to figure out which side it's on. Well, my a value right here is negative, so that tells me that my parabola looks like this. It goes backwards. My focus will be a 1/2 unit this way, and my directrix will be 1/2 unit this way. So from 0, 0 over a 1/2 unit, that's going to be a 1/2 unit in the x direction, so it's -1/2, 0, and then the directrix will be a 1/2 unit over here. And because it's a vertical line, I use x equals positive 1/2.